going on, everybody, and welcome back to the channel. Now today, we got the guy at his channel name is very hard to pronounce, but we've got the largest black hole in the universe size comparison. Now, look, this video has like 50 million views, no surprise, but it's by this one channel that I've reacted to a few videos before, and I've had a few people telling me, you know, where are these sort of videos gone? You know, I guess I've kind of been, you know, busy with the IPL season and the current amount of cricket that's been going on. But hey, we're here. These are the sort of videos where you just, you know, grab your popcorn, sit down, have a listen. Let's waste no time. Let's get into it. Oh shit! Hold on. We need the volume. Also, I've put my face cam in the top right, just because I don't know if I'm going to be blocking anything. We'll see.
Are black holes. In contrast to things like planets or stars, they have no physical size limit and can literally grow endlessly. Although in reality, specific things need to happen to create different kinds of black holes, from really tiny ones to the largest single things in the universe.
Bro, is that
so how do black holes grow? And how large is the largest of them all?
It's true. Bro, you know what is at the end of a black hole? I wonder if you just, like, nothing.
This video will not discuss how black holes work or how they form, since we've looked at that in detail in our black hole and neutron star series.
Okay.
You can check them out afterwards.
Okay.
For now, we're interested in finding the largest thing in the universe. Let's start really, really small. Primordial black holes.
Primordial.
The smallest kind of black holes may or may not exist. If they do, they're probably the oldest objects in the universe, older even than atoms. They would have formed just after the Big Bang, when the universe was so dense with violent energy that any tiny pocket that was just slightly more dense than its neighbors could produce a black hole. The smallest primordial black hole that could still be around would be 8 trillion kilograms or so, the mass of a big mountain. And yet they would be no bigger than a proton. A primordial black hole with the mass of Earth would barely be larger than a coin. This makes them very hard to find, so we haven't actually observed any yet.
We've never found
If
one.
they exist, they may even be the mysterious dark matter that holds galaxies together. Let's move on to the kinds of black holes that we know for sure are out there.
Stellar
black holes.
Okay, I've heard of that actually.
To make a black hole, we need to compress enough matter so that it collapses into itself. After that, the more mass we throw at it, the larger it becomes. In today's universe, only the most violent cosmic events can create the necessary conditions, such as the merger of neutron stars or when the core of a very massive star collapses in a supernova. To have a unit to work with here, we'll use the mass of our Sun, about 2 million trillion kilograms. The smallest known black hole has 2.7 times the mass of the Sun, which works out as a sphere around 16 kilometers in diameter, large enough to cover Paris.
So it's tiny.
Another lightweight black hole is the companion to the V723 Mon red giant star.
What?
This star is 24 times larger than our Sun, 30 million kilometers in diameter.
How much bigger than the Sun? Wait, I thought the Sun was the biggest thing, like, in the universe. Bro, I have so much to learn. Stay in school. Get your education. What?
The lightweight black hole is the companion to the V723 Mon red giant star. This star is 24 times larger than our Sun, 30 million kilometers in diameter.
24, how much? Wait, what? 24 feet bigger? What? Oh, 24 times bigger. That is ridiculous.
And yet, it's thrown around by a tiny black hole just 17.2 kilometers wide.
What?
This tiny thing bullying the star is so much smaller that we can barely even show them in comparison. One of the largest known stellar black holes is M33X7.
Okay.
It currently spends its time eating a 70 solar mass blue giant bit by bit. As all that stolen matter circles towards the black hole, like water going down a drain, friction heats it up to temperatures high enough to shine 500,000 times brighter than our Sun. And yet, X7 is only 15.65 solar masses and 92 kilometers wide,
That's pretty big.
Just big enough to cast a shadow on Corsica.
Oh, never mind.
To grow much larger, black holes have to either devour a lot of stars, or better, merge with one another. The instruments that make it possible to detect these mergers are very new, so we're currently discovering a lot of exciting things. Like two massive black holes that we detected in a galaxy 17 billion light-years away. As they spun around each other violently, they released more energy in the form of gravitational waves than the combined light from all the stars in the Milky Way in 4,400 years.
Bro.
The new black hole they formed is about the size of Germany and is 142 solar masses. And here we hit a curious gap in scale. There are lots of black holes up to 150 solar masses, and then there's nothing for a long time. Until we suddenly hit black holes that are millions of times more massive. Which is a bit confusing because we had this idea that black holes are consistently growing and growing. But for the most massive black holes, this process is not fast enough to explain their existence today.
Bro, I just don't... I'm struggling to understand... Bro, let's just keep watching. I'm trying to keep along here.
Massive black holes to have formed by eating stars and merging with each other. Something else must have happened. To explain,
because I'm just trying to think. You know, we said that we found a black hole that was close, didn't they? Or was it light years away? Because a light year, if you didn't know, is like a long time. It's like 100 years, isn't it, or something like that? Some bullshit. I don't know, but. Bro, I wonder if we got close enough to one, if we'd better, like, how close you could get to it, and if we could get some, bro.
The largest black holes in the universe, we might need the largest stars that ever existed. Quasi-stars. To get a sense of scale, we can compare them to the largest stars that exist today.
Stevenson?
Our sun is like a grain of sand next to them. We don't know if quasi-stars actually existed, but they're an interesting concept when it comes to supercharging black hole development. The idea is that the matter in the early universe was so dense that quasi-stars could grow to thousands of times the mass of our sun. The cores of these stars might have been crushed by their own weight so much to actually collapse into black holes while the star was still forming. In contrast to stars today that would destroy themselves in the process, inside quasi-stars, a deadly balance could emerge. Gravity pressed the supermassive star together, feeding the black hole and heating the material falling in to such a degree that the radiation pressure kept the star stable. And so these quickly growing black holes might have been able to consume the quasi-star for millions of years and grow far bigger than any modern stellar black hole. Black holes several thousand times the mass of the sun and wider than the entire Earth.
That's ridiculous.
These black holes might have become the seeds for supermassive black holes.
That doesn't sound good.
So now we arrive at the kings of our universe.
Oh shit.
The largest single bodies in
Bro,
existence.
like I just can't think. It's always, you know, there's nothing wrong with having an imagination and thinking, you know, to an extent, but I just trying to think, like, I just wonder what would happen if, you know, like, obviously, right, if you went into a black hole, you'd probably just get, you know, burnt alive or squashed up or whatever would happen, sent into the oblivion. You're gone. You're fucking gone skis. But imagine if there's, like, one black hole in the world that, you know, is like a pretend black hole, and that's what people use, like, as an entrance to another galaxy or another world. Like, bro, I don't know. There are so many like, I know this is just talking about black holes, and that's obviously proven science and stuff like that, but like, I just can't help but imagine, what if there is, like, so far away that we'll never get to, but there's just these doors for other galaxies or universes, or, bro, I don't know. This stuff trips me out. It gets me thinking, like, real hard.
The centers of most galaxies contain a supermassive black hole, and they are monstrous.
So the Milky Way,
In the Milky Way, we have Sagittarius A star, a supermassive black hole with about 4 million solar masses that is calm and collected and just does its thing.
Hey, that's pretty cool.
We know it sits there because we can see a number of stars being thrown around by a seemingly empty spot. And despite its incredible mass, its radius is still only 17 times our sun.
Only 17
Smaller than
times.
most giant stars, but millions of times more massive. Because supermassive black holes are so massive and located at the center of galaxies, many people imagine them as being a bit like the sun in the solar system. An anchor that glues everything else together and forces it into an orbit. But this is a misconception. While the Sun makes up 99.86% of all the mass in the solar system, supermassive black holes usually only have 0.001% of the mass of their galaxy.
Wait,
The billions
wait a goddamn minute. Hold on, how does that make sense? Bro, this is... So, the Sun takes up 99.86% of our solar system, but those black holes that he was showing said that they are like 500 times bigger than the Sun. So, bro,
usually only have 0.001% of the mass of their galaxy.
that's little
The
percent.
billions of stars in galaxies
you
are
didn't
not
know.
gravitationally bound to them. Instead, it's the gravitational effect of dark matter which holds them together.
Oh.
Many supermassive black holes aren't gentle giants, especially when they're feeding on the clouds of mass in their galaxy.
They feed on
The
clouds?
one at the center of the BL Lacerti galaxy is devouring so much material that it produces jets of plasma accelerated to nearly the speed of light.
That's cool.
If Earth were orbiting this huge body, it would seem 115 times larger.
Hold on, what's it say? Oh, my face cam is blocking it, but under me it says POV, you are about to DIE. That's what it says. That's what it says behind my
than
face
our
cam.
Sun in the sky, and we'd be burnt to a crisp in seconds by its glowing hot accretion disk.
Oh, shit.
At
What
this
if...
point, black
See, now that gets me thinking then as well. What, you know, people have like bunkers and stuff underground. Does this mean the whole world would just get burnt into a crisp? Like Earth would just like burn alive, the entire Earth? Or, because I'm trying to think like, bro, you know, them underground bunkers, I'll hop in one and I'll be okay. Don't you
15
worry.
times larger than our Sun in the sky, and we'd be burnt to a crisp in seconds by its glowing hot accretion disk.
See, not me. I feel like
At
I've
this
got that
point,
sunscreen.
black holes
so
become
don't
so
you worry.
large that stars seem ridiculously tiny compared to them.
Damn.
The galaxy Cygnus A has a supermassive black hole with 2.5 billion solar masses and 14.7 billion kilometers wide, which would mean that if it took the place of our Sun, it would swallow all the planets and stretch halfway to the edge of our solar system.
Yo.
It's devouring so much mass and material that it churns its disk into a kind of magnetic funnel, spewing gas out, making tremendous radio lobes towering over the galaxy 500,000 light-years in diameter. That's 2.5 Milky Ways wide. Another pretty large supermassive black hole sits in the galaxy Messier 87.
Messier 87.
It has
I think I've been there
6.5
before.
billion solar masses and was the first black hole we got an actual photo of. Or
Oh!
rather, of the glowing gas.
Oh, so that's a real photo. Hold on, I was waiting.
First black hole.
Yo, this is so it actually looks really like what he's pretending it looks like in the video. That damn, bro, like this is the clearest photo that we have of a real life black hole, bro. I'm telling you, if you go straight through this hole, I don't know, you might end up in Futurama. I don't know, but I want to find
We got
out
an
what would
actual
happen.
photo of. Or rather, of the glowing gas
Right.
around the edge of a menacing shadow.
That's-
This sphere of darkness is so large that it covers our entire solar system. And yet, there is a scale even above these kinds of objects.
what?
Ultramassive black holes.
Ultra massive. Okay, here we go.
Now we reach the most massive black holes, perhaps the largest single bodies that will ever exist.
Shit.
These black holes have eaten so much that they've grown to tens of billions of solar masses, their gravity the engine for a quasar, an accretion disk shining brighter than thousands of galaxies full of stars.
Wow.
So massive that they deserve a title of their own. Ultramassive black holes.
Ultra massive.
The ultramassive black hole at the center of galaxy OJ287 is 18 billion solar masses. It's so big that it has a supermassive black hole nearly 40 times larger than Sagittarius A star orbiting it. This thing defies imagination and is really hard to compare to anything. It can comfortably fit 3 solar systems side by side inside of it.
3 solar systems. The entire solar system, 3 times could fit in this one bro.
Let's end this insane competition and get to the King of Kings.
There's
Tara
another one.
618, a black hole that we can observe consuming galaxies worth of matter, is shining with the brightness of 100 trillion stars, visible from 18 billion light years away. It has an incredible 66 billion solar masses. A black hole so large that it would take light a week to reach the singularity after crossing the event horizon.
A week?
About 11 solar systems...
11 solar systems? What is this shit? Bro, what is
could
this?
sit inside of it, side by side.
11?
It may very well be the largest single body in the universe.
It has to be.
But in reality, it's probably even larger. Since Ton 618 is so far away, we only see what it looked like 10 billion years ago. In any case, black holes are scary and mysterious and gigantic. They'll be here after everything else dies and growing larger and larger. Okay, now let's do the trip again.
Okay.
From the smallest possible black hole all the way up to the largest.
Okay. The unicorn. Okay. M33X7. GW190521. Earth. I'm going to try and say them all. Alright. Sagittarius A. Jupiter. No, I'm joking. B. Albacete. Big Meatball. Largest star Stevenson. Cygnus A black hole, Messier 87 black hole, OJ Simpson 287 black hole, and Ton 618. Hey, those are my type of planets right there.
Let's try something new today.
Okay.
We can call it Behind the Lies, a short behind-the-scenes bit about the necessary inaccuracies in this video. Because it's not really actually possible to rank black holes like trading cards.
Oh.
How so? Well, while we've catalogued millions of stars, we really only have good data on a couple of dozen black holes.
Oh.
That's because black hole gazing wasn't really a thing until 50 years ago, and technically still isn't because we can't see black holes. We can only derive their properties from studying their gravitational effects on the matter around them, like the orbit of stars that come close to them. This effect depends on the mass of the black hole, which we can approximate at the most basic level with Kepler's laws. But this comes with huge uncertainties and error bars. Then we have to convert mass to size next, which brings new uncertainties.
Right.
For example, we calculated the radius from the mass using the Schwarzschild equation, which for the sake of simplicity assumes black holes...
Yes, I am actually very, very familiar with this equation. This is my type of mathematics
are
right
perfectly
here.
round and don't spin. A
Yep.
kind of black hole that doesn't really exist.
Yeah, I know that as well.
The reality is that physics on these scales is a bit fuzzy. So some of the black holes we talked about here may be way smaller or way bigger.
Oh, shit.
We just don't know for sure. We shimmied around this problem by comparing different sources with different kinds of values and using different mass calculations to arrive at a standardized list that allowed us to be as accurate as humanly possible. You can look at all of this in our source doc. As a result, this script was written with the tears of experts we drove crazy with our obsession for the best values they could live with.
I bet.
In this process, tons of stuff got cut and didn't make it into the final video.
Really?
But luckily, we found a way to not waste all of it. We've created a lot of black hole merch, spanning the whole range from somewhat bonkers to more serious. This way, we get to explore a topic from different angles, and you get to continue having fun with black holes after this video ends.
Oh! Damn, they were limited for 72 hours. I think this video came out like a year ago, so I think I'm a bit late on the posters. But hey, shout out to the man, Kurzgesagt. Kurzgesagt. We're going to call him Kurzy Boy. Hey, shout out to the man Kurz right here, the largest black hole in the universe. Size. Look, I'm going to need to sit down for another hour after this video and just think about what I've just listened to. Yeah, I think that's going to cap it off. I mean, there's nothing that I can say that is going to explain or even try and put into words what I've just thought. I mean, like this, literally me sitting here for 13 minutes listening to a video and watching it is more than I learned at any sort of science or school class. And that's not even a joke. Like, hey, that's just my opinion. That's just my opinion. But hey, that will cap it off. If there's any other videos by the man Kurz, please let me know because, I mean, this is the best content almost on YouTube. Hey, hope you guys enjoyed. I'll see everyone in the next one.